Math 1342, Section 1.2, Sampling from a Population, Video 2, Examples. Sometimes to introduce a concept or have a discussion, I'll actually go right to the homework section and pick some problems. This is good for two reasons. Number one, the problems usually indicate the skills that you're expected to learn. And number two, we get to model and practice some of the homework questions. So let's get right to it. And again, this PDF is a PDF of the second edition. Your homework will come from the third edition, but the questions are similar in nature. All right, so I've got some questions already highlighted, the odd ones, and we'll just take a look at some of them. Let's go ahead and zoom in on this a little bit, and let's look at question 29. The instructions are to state whether the data are best described as a population or a sample. Number 29, a subscription-based music website tracks its total number of active users. Do you think they are tracking a sample or a population? I'll give you a hint. There's one key word that indicates what the best answer to this question is. Do you know what that word is? Total number of active users, excuse me. Highlighted the N, let's fix that. Since they are tracking the total number of active users, that's all of the population of interest. So it would be safe to conclude that this data represents a population. Let's take a look at question number 31 and ask the same thing. A questionnaire to understand athletic participation on a college campus is emailed to 50 college students and all of them respond. All right, this is kind of tricky. It's not too tricky. Would you say that this, set of 50 college students, all of who responded, is a sample or a population? Well, if you're talking about college students, and you say it's a population, then you are saying that there are 50 students at this college. And although that's feasible, it's more likely that there are more than 50 students at this college. In fact, I'm not sure if 50 students could sustain a college financially in terms of their tuition, unless it's crazy expensive. Since we're only talking about 50 students, it's safe to assume that this is a sample. Now, if you said population because of the word all, that just means all of the sample did something. But more than likely, there are more than 50 students. Here's a not so subtle hint. If they're talking about a set of cases or units and they give you a specific number like 50, then most likely it is a sample. Because if the population were that big, then there would be no need to do statistics on it at all. Or rather inferential statistics, I should say. All right, let's look at the next batch whose instructions are right here. Describe the sample and describe a reasonable population. All right, let's take a look. Number 33. 500 Canadian adults are asked if they are proficient on a musical instrument. Well, the sample is 500 Canadian adults. And if that's the sample, then what should the population be that they are representing? If you said all Canadians, you would be incorrect. Because all Canadians would involve children as well, but they sampled 500 Canadian adults. And so the population that this sample is representing are all Canadian adults. Let's take a look at question 35. A Nielsen Corporation attaches data boxes to televisions in 1,000 households throughout the US. Let's highlight that sample. 1,000 households throughout the US to monitor what shows are being watched. I'm sorry, 10,000. No, that is 1,000. My eyes were playing tricks on me. 1,000 households throughout the US to monitor what shows are being watched and produce the Nielsen ratings for television. So what do you think the population of interest is? Households throughout the US. That sounds reasonable, but there's something that all 1,000 of these households have in common. That's implied by the problem. There are 1,000 households that have televisions. So even though you could say that this is a sample from the population of all households throughout the US, in order to have a data box on their television, they must first have a television. So a better description of the population would be households throughout the US that have televisions. Now, If the Nielsen Corporation was trying to make a claim about the entire population, then their sample doesn't accurately represent the population because they would have to include some people in their sample whose households do not have televisions. Of course, then there wouldn't be any data, but these are things you have to think about when you're choosing samples. All right, let's move to the next batch of questions. For each let's see, in these questions, a biased sampling situation is described. So we're being told it's biased, which means something happened that caused the sample to not accurately reflect the population. In each case, describe the sample, the population of interest, and a population we can generalize to given the sample. All right, let's look at number 37. To estimate the average number of tweets from all Twitter accounts, right here they tell us this is the population we are trying to find out something about. One of the authors of what? I guess one of the authors of this book. One of the authors randomly selected 10 of his followers and counted their tweets. So which one is the sample? That would be the 10 followers of this author. But what's the population they're investigating? All Twitter accounts. However, this sample is not representative of all Twitter accounts because these 10 followers have something in common that the entire population doesn't. What do they have in common? Well, they follow the author. So the sample would better reflect a population of all of the author's followers as opposed to all Twitter accounts. In order for it to reflect all Twitter accounts, he would need to randomly select from all Twitter accounts, not just from his followers. All right, number 39. Now, again, we're trying to find the sample, the population of interest, but the true population we can generalize to from the sample. Number 39, to determine the height distribution of female high school students. The rosters are collected from 20 randomly selected high school girls basketball teams. All right, they are trying to find out something about the height distribution of female high school students. Let me erase that. Our population of interest is female high school students, but where did the sample come from? 20 randomly selected high school girls basketball teams. Do you think selecting students on the basketball teams would have an influence on the height of these students? The answer is probably. I know in high school there are some tall female basketball players. I've also seen some short ones that are good and medium ones that are good as well. But in general, it's safe to conclude that on average, basketball players are taller than the general population. So selecting 20 randomly selected high school girls basketball teams would not be a good sample to reflect all female high school students. What population would it reflect? Well, all high school girls basketball players. All right, let's move on to this next batch, Skill Builder 4, if you will. I just like changing colors at random. And the next exercises state whether or not the sampling method produces a random sample from the given population. It's interesting how the author abandoned the word simple and just said random sample. All right, so are these randomly selected samples? Number 41, the population is approximately 25,000 protein coding genes in human DNA. Okay, each gene is assigned a number from 1 to 25,000, and computer software is used to randomly select 100 of these numbers, yielding a sample of 100 genes. Is this a random sample? Yes, this is equivalent to drawing numbers out of a hat and using well, it explicitly says technology randomly selecting 100 of these numbers. In fact, in some events that I conduct at TJC where we have to draw people at random, I actually do exactly this. I list the names on a spreadsheet, number in from 1 through whatever, and then I will ask Siri, hey Siri, pick a number from 1 to 500.
A random number between 1 and 500 is 357.
I'm sorry, I'm holding this up to the screen as if you could hear it. Siri said a random number from 1 to 500 is 357. So yes, this is definitely a random sample. All right, let's take a look at number 47, 49, and I think that's all I have highlighted. Yes. So we're almost done. All right. Oh, I'm sorry, 43. We're still asking the question, is this a random sample? All right, number 43, a population. Did we do that one already? Oh, we're still answering the question, does the sampling method produce a random sample for the given population? All right, 43. The population is adults between ages of 18 and 22. A sample of 100 students is collected from a local university, and each student at the university had an equal chance of being selected for the sample. All right, I want to make sure I read the instructions closely. Instructions said, state whether or not the sampling method described produces a random sample from the given population. So there's two key things to look at here. A random sample from the given population. The given population here, it says it at the beginning, is adults between the ages of 18 and 22. The sample was 100 students, and each had an equal chance of being selected, which means it's a simple sample, if you will. But does this sample reflect the given population? I keep forgetting the wording that they used. Does random sample from the given population? So is the sample of 100 students a random sample from the given population? And the answer is no. I know they'll have an equal chance of being selected, but think about it. What is the population we're studying? All adults between 18 and 22. But where did the sample come from? A local university. Unless all adults between 18 and 22 go to this local university, this is not a random sample of that population, because not all elements of the population could have been selected, only the students at this local university. Is it a simple sample? Yes, because each element had a equal chance of being selected, but it's not a simple random sample because not everybody from the population had a chance to be selected. All right, last couple of questions, I believe. Yes. All right. Is it biased? Indicate whether we should trust the results of the study. Is the method of data collection biased? Explain why. We didn't actually define biased, so if you give me a second, I'll swing back up here just to show you what it is. I mean, we kind of intuitively know what it means, but bias, here it is. Here's the definition. Bias exists when the method of collecting data causes the sample data to inaccurately reflect the population, which sounds a lot like sampling bias, but it's basically saying when we chose our sample, we did something to not accurately represent the population that we're trying to infer about. All right, so should we trust the results of the study? Number 47, ask a random sample of people in a given school district, and here's the question we're asking. Excellent teachers are essential to the well-being of children in this community, and teachers truly deserve a salary raise. Do you agree? Use the results to estimate the proportion of all people in the school district who support giving teachers a raise. Do you think the results of this survey would accurately reflect the opinions of the population? Think about the question. Well, notice the question starts out, well, fairly biased. Excellent teachers are essential to the well-being of this community, and teachers truly deserve a salary raise this year. Do you agree? Just the way the question is phrased, you're already biasing the person answering the question with your choice of adjectives. Whenever you're surveying a sample to get some data, you should try to make sure that your questions and your phrases are as unbiased as possible, but making them objective instead of subjective. So how could we make this a more objective question? We could simply say, do you think teachers deserve a salary raise this year? End of story. By laying out this first batch about excellent teachers, et cetera, you're already influencing the answer. So no, we can't trust the results of the study. And you'd be surprised how many professional companies like news companies and media companies are really bad about collecting data without bias. Number 49, take a random sample of one type of printer and test each printer to see how many pages of text each will print before the ink runs out. All right, taking a random sample of one type of printer. Use the average from the sample to estimate how many pages, on average, all printers of this type will last before the ink runs out. Should you trust this study? Well, we took a random sample. We did one type of printer. Is there any bias in that? No, if we're just picking printers at random, we're not. And we're doing the exact same thing for each one to measure how many pages it'll print before it runs out. Unlike the previous example, there doesn't seem to be any anything about choosing the sample that would influence the outcome one way or another. So this would be an example of a let's see, study that we can trust because the method of data collection was not biased. All right, your homework assignment for this section, when I assign it, so keep an eye on Canvas for it, are going to contain questions just like the ones I answered. That's why I was doing the odd ones, because I know they're answered in the back. The even ones in your book will be left for you. So keep an eye on Canvas for that homework assignment.